Hi, I am Syed on Maths Online. Today we will be discussing one property which is orthogonal property. To understand orthogonal property, let me consider these two curves. So this is one curve I am taking. So let me take another curve in this form. So they are intersecting at one point. Suppose if I draw a tangent at this point, and the tangent for this curve if I draw, now suppose if the angle between these two tangents is 90 degree. If the tangents are intersecting at 90 degree, then we say these two given curves intersect each other at right angles to each other, or you can say that the two curves are intersecting orthogonally. Right? So that's the basic definition for orthogonal curves. So we say that these two curves are orthogonal to each other. Now we'll try to prove one result. So let us take if f of z is equals to u plus iv is analytic, then the family of curves u of x comma y is equals to c1 and v of x comma y is equals to c2. So these are the two curves I am taking, where this c1 and c2 being constant, these two curves intersect each other orthogonally. They intersect each other orthogonally. So just now I have shown you the definition of orthogonal curves. So suppose if I take one of the curve to be equals to, it is u of x comma y is equals to c1. If I take another curve as v of x comma y is equals to c2, here I have to show that these two curves intersect each other orthogonally if this function f of z is analytic. So let us try to prove this result. So I have already given the definition of orthogonal curves. So let us write down in the form of the statement. So I'll just write down in the form of statement. We know that two curves intersect each other orthogonally if the tangents at the point of intersection are at right angles. So if the tangents are intersecting at 90 degree, then the two curves are said to be orthogonal. We know that this derivative dy by dx, what does this represent? This represents the slope of the tangent. So this dy by dx will represent the slope of the tangent. And what is the condition for the two curves to be perpendicular to each other? And we already know that the condition for perpendicularities of two lines. So what is the condition for the perpendicularity of two lines? Suppose if I consider the slope of the first line to be m1 and the slope of the second line to be m2. So we know that the product of the two slopes will be equals to minus of 1. So this is the condition for the two lines to be perpendicular to each other. So using this condition for the given curves u and v, I show that the two curves are perpendicular to each other. So therefore, now we'll try to consider the first curve. Consider the curve u of x comma y is equals to c1. Now let us try to differentiate this u with respect to x. Differentiate u with respect to x. Treating y as a function of x. Y as a function of x. So therefore, if I try to differentiate this u with respect to x, I will be getting dou u by dou x plus. Now, once again, first I have differentiated this u with respect to x. Now I have to differentiate this u with respect to y. So which means that I have to differentiate this u with respect to x and y. So first I have differentiated this u with respect to x partially. Then I will try to differentiate this u with respect to y. So u is being differentiated with respect to y. And I am taking y as a function of x. Therefore, derivative of this y with respect to x will be dy by dx. Right? So that will be equals to, on the right hand side, the constant derivative will be 0. Further, if I try to simplify this, I will try to find out the value of this dy by dx. So send this dou u by dou x on the other side. So dou u by dou y into dy by dx is equals to, so dou u by dou x comes on the other side, becomes minus dou u by dou x. Or further, this dy by dx will be equals to, right, dy by dx will be equals to, so this minus dou u by dou x will remain as it is. Cross multiply this value, so that becomes whole divided by dou u by dou y. Right? So this particular expression, suppose if I am taking this value to be equals to the slope, because I already told you this dy by dx represents the slope. So what I have calculated over here is nothing but the slope of the curve u. So let me take the slope of the first curve to be m1. So for the curve u, I have evaluated the slope m1. Similarly, let us try to find out the slope for the curve v. So similarly, for the curve v of x comma y to be c2, what will be the slope? Dy by dx. Right? So I can similarly write down only the same expression. In place of u, I will try to write down v. Or else you can follow the same procedure and write down, or else you can write it directly. So I'll just write it directly, just replace this u by v. So you will be getting minus dou v by dou x whole divided by dou v by dou y. So once again, this dy by dx represents the slope. For the curve v, I will be taking the slope to be m2. So I have obtained the slope of the curve u as well as the slope of the curve v. So now we know that the condition for the two curves to be perpendicular is m1 m2 to be equals to minus of 1. So I have to show that m1 m2 is equals to minus 1. Then we can conclude that u and v are orthogonal to each other. So therefore consider m1 m2. So let us write down m1 value. M1 value is this. It is minus of dou u by dou x whole divided by dou u by dou y. Right? Then m2 value is this, minus dou v by dou x whole divided by dou v by dou y. So I have written both the values. Now if you go back to the statement, in the statement it is given that f of z is analytic. So if f of z is analytic, in that case this u and v has to satisfy the Cauchy-Riemann equation. So what is given? So but given that f of z is equals to u plus iv is analytic, therefore, and hence the Cauchy-Riemann equation will be dou u by dou x is equals to dou v by dou y, and dou v by dou x is equals to minus dou u by dou y. So these are the Cauchy-Riemann equations. So now if I try to plug in these equations back over here in this particular equation, so let me take this as equation number 1. So you can put this value back over here. So let me take, I'll try to replace the numerator values, retaining the denominator values as it is, just replace the numerator. So therefore equation number 1 implies m1 m2 to be equals to, right? So you can see that dou u by dou x will be what? Dou v by dou x. So minus of, so we have dou u by dou x to be equals to dou v by dou y. So it becomes dou v by dou y. Right? Denominator I'll retain as it is, dou u by dou y as it is. Here minus dou v by dou x. So dou v by dou x is minus dou u by dou x. So this minus of minus will become plus. So we'll be getting dou u by dou y. It is whole divided by, denominator will be retained as it is, dou v by dou y. Now you can just see that the numerator and denominators will cancel out. So you can cancel out the numerator and denominator values. So you can see this dou v by dou y will cancel out with this dou v by dou y. This dou u by dou y will cancel out with this dou u by dou y. Right? So what is left out over here? So we can see that only minus of 1 will be left out over here. So therefore we have got m1 m2 to be equals to minus of 1. So the condition for perpendicularity has been satisfied. So what can you say about these two curves u and v? You can say that u and v are orthogonal to each other. So hence we can conclude that the curves u and v intersect orthogonally. They intersect orthogonally at every point of intersection. So wherever the two curves intersect, they intersect orthogonally. So hence the curve intersect orthogonally at every point of intersection. So hence we have shown that u and v are orthogonal to each other. So that's all I have for today. Thank you.